Hello, good morning.
Good morning, sir.
This meeting is being recorded.
So, what we have discussed so far yesterday, we have discussed about the
Cla-
micro particles. How,
Cla- Classes and cloud computing things.
yeah, cloud computing concepts, and what is the advantages over on-prem systems to, I mean, traditional systems to cloud computing. Then we have discussed about the micro partitions, how the data will be stored in Snowflake in the
Okay.
backend,
Yes.
uh, and some part of catching. What are the types of catches we
Yes.
have?
Yes.
All this concept, right? So uh, we'll quickly recap the session again, yesterday's session. The micro partitions. This is important concept. You should know how the data is being organized in Snowflake at the back end. Anyways, this would be taken care by Snowflake, but if you know this, then you can correlate this concept with some other concepts also, like time travel, cloning, everything. So that is the reason I'm trying to reiterate it again. So in Snowflake, the data will be stored in form of micro partitions. Okay, if you have large amounts of data like 100 GB of file, it will be divided into multiple micro
Micro
partitions, and
partitions.
it will stored in storage layer. Okay, in each micro partition, how the data will be stored is in columnar format. Okay, so here if you see the micro partition one, it have the data of first six records. Okay, so all the first six records also, see, the first block of first micro partition is having only the content of the first column type, right?
Yes.
And the second block of micro partition have the
Name.
data of
Name.
name column. So like this, even if your table have 15 columns, it will have 15 blocks in every micro partition. Okay, you understood, right?
Yes, sir.
Hmm. So here the micro partitions are immutable. What does it mean? For suppose if you are creating a table and you are inserting 1,000 records. Okay, after some time, as soon as you create the table, it will be as soon as you insert the data into the table, it will automatically stored in storage layer in terms of micro partitions. The Snowflake will divide that large amounts of data into small micro partitions, and it will store in storage layer. Okay, for suppose 1,000 records you have inserted, and if you are updating the data, if you are updating that 100 records out of 1,000, okay, then it will not change the micro partitions data. It will not change the data which is available in micro partitions. Okay, whatever the data it has changed in your micro partition, it will mark as delete and it will create new micro partition. Okay, so how long the micro partition, the micro partition which is marked as delete will be available is up to your retention time period. Using time travel, you are going back and trying to fetch the historical data, right? So how it will work is like this. Even it will store the micro partition as it is. It won't change. It won't change the micro partition. It will mark as the delete. If once the micro partition is marked as delete, even if you try to get the data using select command, it will show only the updated content, not the old content. Okay, and if you are going back and trying to get the data using time travel, then within the retention time period, I'm specifying this word again and again. Within that retention time period, if you specify 10 days of retention time for a table, then the deleted, the mark, it will, I said right, it will mark those micro partitions as delete, and it will create new micro partitions with the updated data. So the deleted micro partitions will be internally stored for 10 days only, up to what retention time the table have. Okay, so if you are trying to access the data using time travel, it will go to that particular micro partition which is marked as delete, and it will give the data at that particular point of time how it was showing. Okay, is it clear now? And one more thing, what we have discussed, the primary key and foreign keys. In terms of interview perspective, I have said.
Yes, sir. There is no primary key and foreign key, sir.
In Snowflake, we can use primary key and foreign key, but they are, the characteristics of primary key and foreign key are not enforced in Snowflake. Okay, what does it mean? For suppose, what is meant by primary key? First of all, see, for suppose if you have, okay, if you have a table, okay, if you have a table, if you mark this column EMP-ID as primary key, this column will never allow to insert null values and duplicate values if it is primary key in relational databases. But here, even if you mention any column as primary key, it will allow you to insert the duplicate values and null values also in case of primary key. If you don't want to allow null values in this particular column or any other column, then you can mark as not null. Okay, so let me try to show you this quickly for next 2 minutes, and we'll jump into the next topic. Okay, I have created this table and I am trying to insert. I think this we have seen yesterday, right? Okay, we have inserted, but I think we have not shown. See, I have inserted one record. Okay, just now just try to see the data, what it is available.
Select star from.
Start from table name. Okay. If you see, the record which we have inserted is there in the table. Okay, you try to insert one more column, one more row, one more record, 16 and 15,000, 15, and here I am not giving any value for this employee location. Okay, I'm not giving any value for this employee location. See, even if you don't give any value to this column, are you able to insert the record or not?
Yes, sir. We are insert.
So here it is allowing the null values. Even if you don't mention, it is allowing. See, here the particular column, particular record column for employee location is empty. Okay, so again I'm trying here while we are creating the table, here we have marked this EMP-ID as not null, so it should not allow any null values. Let me try to insert one more record and show you. Okay, I'm not giving any value, and here I am giving okay. It will throw error because we have marked this first column employee ID as not null. It should not be null. Okay. Okay. Now let me try to create. Let me try to recreate the same table, and here I am marking. Okay. Let me show you. I think now you are able to understand, right? Here employee location we are able to give the null values. Or see once again, and here I am specifying as null. We'll see now. See, don't get confused with without giving. See it. We have inserted one more record with 22 temp 15,000 15 null. Okay. Now cell C. See what it is updated. Null. So you don't get confused with without data and null data. See, for suppose if somebody say that you have 0 rupees, you have 0 rupees. What does it mean? You don't have any money with you, right? Here it is also saying, if you are saying that this record has null values, means you can correlate with the statement what I am saying. If somebody is saying that you have 0 rupees, then which is nothing but you don't have any money, right? And if you say directly that you don't have any money, both are same, right? Is it clear now? I hope this is clear. Okay. So we'll move to the next topic. So this is clear, right? No, even you don't require this much, the primary key. See here, there it is. Okay, here even without giving any data here, you are able to insert. But if you mark this specified column, where we are trying to insert the record without mentioning the data, EMP location, right? Last record here, employee location. If you mark this specific column as primary key in traditional databases, it won't allow to load the data if you are not giving, if this is empty or null. But here in Snowflake, even if you mark any column as primary key, it will allow you to insert the records null values or without data. Clear? I think it should be clear now. So we'll go to the catching now. Yesterday I think we have discussed. See, this document is shared already with you. Okay, just go through it. So catching. What is meant by catch? Cache memory. In general, what you know about cache? It's a temporary storage memory. Even in your computer also there will be cache, SSD. Apart from hard disk you'll have cache memory. So if you are trying to retrieve some data, if it is available in cache, then you don't need to go to your hard disk or hard disk and get it, right? Okay, but suppose let me show you. This is the user, and you have cache, and then permanent storage or HDD or in Snowflake storage layer. Okay, if you are trying to access the data, if it is available here itself in the first step, for suppose in first step itself, then why to go to this hard disk and get the data, right? See, for suppose if you want to have something, if you want to buy laptop, okay, if you are staying in Marthalli, And if the laptop store is available in Marthalli, whether you will go to BTM and buy, or whether you'll go and get the laptop in your nearest store. Obviously we'll get it from your nearest store, right? So same way here it also works. As soon as you give a query, if it will check whether it is available in result cache or metadata cache or virtual warehouse cache. If it is not available, then only it will go to the storage and it will fetch the records. Okay, so here we should understand what is the major differences between metadata cache, result cache, and warehouse cache. Metadata cache is nothing but, see, in this cache, it will be maintained by cloud services layer, where all the statistics of the data which you will store in your storage layer. Only that information about the stored data will be available here. For suppose, what kind of statistics? It will maintain the data like how many rows are stored in that particular table. For suppose, if you have any employee table, how many rows, the number of rows, not the complete information. It will store only the number of rows in metadata cache. And what is the size of the size of that component, size of that particular table? Okay, where it is located, what are the micro partitions, how they are designed. See, metadata information related to micro partitions. Okay, what is the range? I've said right already, the data will be stored in terms of micro partitions. It will be divided into multiple micro partitions. For suppose, if you have 1 TB data, it will be divided into micro partitions, different micro partitions. How many micro partitions is it will take care of? It will be taken care by Snowflake. It will decide based on depends upon the size, and it will divide into small micro partitions, and it will store the data in the storage layer. Okay, so range values, which is nothing but which micro partitions have which data. One second, let me try to explain. Micro partitions, right? See here, so the metadata cache will contain the data. See here, we have this table, right? First six records we have in micro partition 1. So here the range is nothing but the range values is nothing but first micro partition have data from which to which, I mean which row to which row. Here if you observe, this first micro partition have the data from first row to sixth row, 1 to 6, first to six rows. It is stored in, see here, are you able to see? I'm trying to zoom it. I think I can't zoom it or what. Okay, here I'll zoom it here. See here, what it is showing, micro partition 1, rows 1 to 6. The range is the minimum, range from 1 to 6. First to 6 records. 6 records it is storing in micro partition 1. And here in micro partition 2, what is the range of this micro partition 2? 7 to 12. 7 to 12 records. This is the range values. Is it clear now? So Snowflake will store metadata cache, will store those kinds of data. And when you are trying to give a query, and if if you want to get the data from storage, then the technique, I've told, if you are trying to retrieve data, then it will search for only few micro partitions which is available. If you are trying to give access the data if you have 1000 records in your table, if you are trying to access only 500 records, 500 records will be stored in, for suppose if 1000 records are divided into 10 micro partitions. If you are trying to retrieve only 500 records out of 1000, then Snowflake will go and search only the micro partitions which where these 500 records are stored. Instead of scanning all the 10 micro partitions, it will scan only the micro partitions in which the 500 records are available. So here, the efficiency also would be more, right? The performance would be more. Instead of searching 10, if it is searching only specific micro partitions, then that technique is called pruning. This we will discuss when we, in the next topic, the coming topic called performance optimization. Okay, so the pruning technique the Snowflake will use to fetch the data. Okay, let me go through the real time comments, and I will show you the examples. Okay, catch. So here, see, just try to understand how it is getting. I'll show you. See, what I have told in metadata catch, it will store the count of the rows. See, row count of the rows. It will store the count of rows, right? So here I am trying to retrieve, see the count of this particular table, item table. Okay, see now see the compute warehouse. We are not utilizing any warehouse. It is not active. Okay, try to run this command. See, it has given whether it used warehouse. It has not used the compute warehouse, any warehouse, right? Directly it has given, because warehouse is meant for computing. If you want to communicate with the storage layer, or if you want to do some aggregations, then you need compute resources. But this metadata cache will be maintained in cloud services layer only. It is the top layer. Okay, see here. Where it is? Yeah, see here. In cloud services layer only, the result cache and metadata cache will be available. In warehouses cache, all the warehouses will be, virtual warehouses, compute resources will be available. For each compute resources, there will be cache. For suppose if your system, your PC, your laptop is a compute resources, your PC also will have cache. Okay, these resources are, the compute resources will have memory cache. I think when we are discussing about the warehouses in the architecture, we have discussed about this, right? Okay, so when you are inserting records, or when you are trying to get records from storage, then it will retrieve, it will get the raw data and it will store in virtual warehouse cache. Okay, so this way, even if you try to see the count of this count of records on this particular table, it has not used any compute resources. Okay, see here, I'm trying to select minimum and maximum of this particular column. Minimum and maximum range values. See here. This is the minimum value. This is the maximum value. Go to the query history and check. This is the recent query we have executed, right? Go to click on the query and see here row count. Why it is showing like this now? See, it is these two rows are retrieved from These two are retrieved from column result catch. Why? This we have executed yesterday once. What I have told, the result catch values, in result catch, the data will be stored for 24 hours. 24 hours. Okay, let me try to show you. See, this is sum. Sum is the aggregation function. This is not any statistical function. Sum is aggregate function. If you run this, I think this also we have run yesterday, I think. Yeah, see whether the compute warehouse is enabled or not, because it has to go and fetch the records from storage. See whether it has scanned table or not. Remote disk IO. Remote disk IO is nothing but 100%. 100% data we got from remote disk IO. Okay, so see aggregate here. It has not used any. One second. It has not used any result catch or this warehouse catch. Completely all the records you got from remote disk. Remote disk is nothing but the storage layer. Okay, see 100%. See, we got these two are 0%. You got, it has scanned the table and you got this result. Okay. So now if you run the same query again, we'll see. See, again I am trying to suspend this warehouse, compute warehouse, right? Okay, let me go to the warehouse and suspend, which is compute warehouse, right? Compute warehouse. This I'm suspending this warehouse. Okay. Why it is not suspended? Okay, so it is suspended, right? So I am trying to execute the same query. Then we'll see whether whether it used the compute resources now. It has not used. Why? Because we have run this query just before. So the results will be stored in result catch already. Okay, for the first time when you are running a query, it will go and get the data from storage layer, which is remote disk. After that, if you are trying to run the same query, exact query, the same results will be reused. Go to the history and check. See what it is showing? I have run the same query again. What it is showing now? Query results reuse. Okay. So when we run the query for the first time, it will go and get the data from remote disk. Remote disk is nothing but storage layer. After that, once you get the results, it will be stored in your result catch. How long it will be stored? The result catch in your the results in results catch for next 24 hours. Okay. So see here. I am trying to run this data. I am trying to retrieve the data. And you see one more thing. See, this is the query we have executed first, right? I mean sum. This is the first time. Then we have suspended the warehouse. Then again we have run the same command for the second time. First time, whether it is using the warehouse or not. Even we have not enabled. It has utilized the compute resource, the warehouse. And what is the time it has taken to fetch the results? 400 milliseconds. Where here, if we are running the same query, it never used the warehouse. And uh, in how much time we got this results? 118 milliseconds. See how much efficiency it is. Here, I'm just showing you for your understanding. For suppose if you are executing, if you are running a query on 10 TB data, on large amounts of data, then it may take 20 seconds, 15 seconds, 30 seconds, like that, right? When you are trying to execute the query for the first time. And if you are running the second query, as it will be available in result cache, you will get it in milliseconds, not even second, not even 1 second. Okay, so that the performance would be more, efficiency would be more. See here, I am trying to fetch the data. How much time it is taking? See. See, when you are dealing with large amounts of data, it will take more time to fetch the records. It has to scan all the micro partitions, right? It has to scan complete table. See how much time it is taking to fetch the records. Let me show you now. See, 38 seconds, still it is running. 44 seconds, still it is running. 50 seconds. So if the data is the data volume is more, then it will take more time to scan and give the results. Okay, so if you run the once this scan is complete, if you run the same query, again, it won't take this much time. It will never take this much time. Okay, so for that way, in that way, you will improve the performance. The performance will be increased, right? So like that you will get the performance through caches. Okay, so here you are running the query for the first time. See here how much time, how many records it is showing. I think 1 crore, 10 crores records. It took 1 minute 53 seconds. Now go to the history and check. See, this is the command we have run. This is the output we got for that record, for that query. Okay, so go to the profile, go to the query profile and see how much time it took. How much time it took? 1 minute 52 seconds, right? You go and rerun the same query again. It took 1 minute 52 seconds or 53 seconds. So if you go and run the same query again, how much time it took to display the same content? See here also it fetch same number of records. How many rows? 10 crore rows. But it is given the time within 240 milliseconds, even not a second, not a single second, less than 1 second. So here in this way, the delay is less, right? Because it has stored the results in result cache. Now go to the history and check. See here, it has used warehouse. See, if your warehouse is size is a bit more, then it won't take this much time. Okay, because here we are using XSmalls, that is the reason it took this much time. If your if your warehouse size is a bit more, L or small or XL, it won't take this much time. See here, whether it is used any warehouse here. Same query we have run 2 times. First time it has used warehouse to fetch the data from table, but here it never used warehouse because it got the result from cache memory, result cache. If you go to the query profile, what it is showing? Result reuse, right? Is it clear now how the caching is worked? So we have one more cache, warehouse cache. Okay, we'll cover that scenario also. Meanwhile, the metadata cache will be managed by Snowflake only. Metadata cache will be managed by Snowflake only. It will be up to date. If you are inserting something, if you are deleting, apart from that, even if you insert, it will update the metadata cache. It will be up to date. It will be taken care by Snowflake only. No need of backup, backup, everything will be taken care by Snowflake. But here in result cache, how long it will be available? It will be available. See, we have run this query now, right? Let's say 9:38, 1 minute back. If you run the same query tomorrow before 9:38, you will get within this time, less than 1 second. But if you run after 9:35, 9:39 or 9:40, again it will take time, because after 24 hours automatically the result cache will be cleared. Okay, but suppose if you are using this query, so the results cache will be, the results will be stored in result cache. But suppose if you are executing the same query after 1 hour, you will get the results from result cache, right? So let's say you have run this query at 9 a.m. today. Okay, and again if you run the same query, so okay, once again guys, let me show you clearly. Okay, if you run this query today at 9 a.m., so how long the results would be available? 9 a.m. tomorrow, right? So the results will be available in result cache for this particular query for next 24 hours. The results will be available till 9 a.m. tomorrow. If you are executing the same query at 10 a.m., same query, exact same query, again today, so the results will be available in results cache till 10 a.m. tomorrow. Okay. For suppose if you are executing the same query, so the results will be available till 10 a.m. tomorrow, right? If you execute the same query tomorrow at 9:50 a.m. Okay. Then how long the results will be available in the result cache? Same results. Day after tomorrow, no, the results will be available
just only one day
till 9:50 a.m. day after tomorrow. Okay, so as soon as you are re-executing the same query, the timestamp, the offset time is getting increased. It is getting reset, and from that particular time when you are executing that query, from that particular time it will be available for next 24 hours, right? So then this way, how many days it will be extended? This is a sort of interview questions they may ask. Even if you ask few people who are working real time on Snowflake, they also might not know. Okay, so it will be extended up to 30 days. 30 days. Okay, is it clear now? What I am trying to convey, if you understand, that is enough. If you are getting what I am trying to say, then you will be able to explain. Is it clear or any doubts? Hello, Sridhar, Manikanta, Varun. If it is clear, then we'll move to the next.
No doubts to this.
Okay, is it clear, right?
Is it clear, right?
Okay. Okay. So this way, the result cache and metadata cache will work. Okay. So the result cache will be available for next 24 hours. Okay, 24 hours. And how many days it will be extended? If you are if you're rerunning the same query, it will be extended up to 30 days. Okay. See, I think I have shown by running the same query twice, right? How it would be. Here I am running the query. In the first run, you may get the results from table, remote disk, or storage layer. If you rerun the same query, then it will directly return the results from your result cache. Okay. For suppose, let me show you. Let it finish. Even while running, also you can resize the warehouse while running a query also. But I've said, right, when we are discussing about warehouses, multi-clustering warehouses and virtual warehouses. Even while running the query also, you can resize the warehouse. You can increase or decrease the warehouse. But the currently running query will run on the same size warehouse. The next running queries will be running on the changed warehouse, increased or decreased warehouse. Okay, see here, we run this query for the first time. Okay, yeah, this query for the first time. Go and see in the result cache whether it got the results from result cache, or whether it got results from okay, this one, right? After that, we try to change the size. Okay, that is the reason it is showing. Okay, this query we have run, right? See, same query, right? Yeah, the same query. Go to the query profile. See, it has scanned, it has processed, and 1% from local disk IO, which is virtual warehouse, and remote disk IO 45%. 45% means remote disk is nothing but storage. Synchronization, initialization. It will show all the profile, query profile, how it got the results, everything it will show. Okay, so sometimes they may ask you in the interview, uh, mm, if you want to check the query history, but query no, I'm not intent to say particular query history, where from where the results got and all. If you want to check where you will get those results, in that way you may expect interview questions. Okay, where you are getting the history of particular query? In query profile, right? Query profile, go to the history and click on the query ID. Then in the profile, here it will show details and profile. Details will show everything, what is the query and what are the results you got. And in the profile, it will show the detailed information from where it has fetched everything. Got stuck again. Okay. So is it clear now? See here. Here you might be having different warehouses for different teams, right? In your organization. Or suppose if your reporting team is there, they might have some warehouses dedicated to them, and if development team is there, they might have some. Still loading. They might have some dedicated resources for them. This is recording, right? It is recording. Okay. So like that. Okay. So if okay, let me finish the virtual warehouse cache also. Then I'll tell you that particular scenario. So what all the data will be available metadata cache? I've told what is the count. I mean, how many records are there, the count of the records, the size of the table, and the minimum maximum range values of the micro partitions. In micro partitions, what is, from which row to which row the data has stored. All these file references, where the table and files are stored in the storage. Okay, so all these will be available. See here, if you are when we run the query, which is count, with the count, then it has written the result from metadata cache. We have seen that already, right? It has not used any warehouse also. Here I have shown, right? Hmm. See, I have run this query, count of star. It has not used any compute resource, and we got this result from metadata cache. I think we'll see. One second, history, right? History. Refresh it. See, here it is showing query result reuse. Why? Because I have already run this query. Before 10-15 minutes. So the results are stored in result cache. So in this point, what you will understand is, even if you fetch the data from metadata cache for the first time, from the next time, if you are trying to run the same query, you will fetch that from result cache. Okay, see, for the first time when you are running the query, if it will search whether you are trying to get a kind of aggregated, not aggregated. If you are trying to get data, a kind of the minimum count, the minimum value or maximum value or count, this type of data, then it will directly go and fetch from metadata cache. Okay, so when you are giving a query, first of all, that it will be looked into the result cache. If it is not there, then it will go to the metadata cache. Okay, so here when we run the same query again, it was searching the results in result cache. It is available in result cache itself, so it returned again directly. When you are running a query for the first time, then it won't be, the result will not be available in result cache, right? So it will scan the result cache. If it is not available, then it will go and search in metadata cache. If it is available, it will return. Even if it don't find any results in metadata cache also, then it will go and search in warehouse cache. Still, if we don't find any related results for that query, then it will go and search from remote disk. Okay, even if the data is not available in remote disk also, then it will throw an error. Okay, this is the way the query will execute. See the result catch. This layer holds the query results for 24 hours. I have said, right? If you are running a query now, then the results, the results which is providing by that particular query will be stored in result cache. How long it will be stored? 24 hours. If you are running the query again after 12 hours, then from that particular point, again it will store next 24 hours. Okay, how many days it will be extended till 30 days. Okay, so query results will be available across different warehouses. See, you know, if you are using a compute warehouse in this worksheet, and in some other worksheet, if you are using some other warehouse, okay, all the results will be stored in uh, compute layer, right? Not compute layer, cloud layer, cloud services layer. 1 second, guys. See here in the beginning itself I have shown the result cache and metadata cache will be stored in cloud services layer. Okay, here it is what I am trying to say is query results, whether you got the result from by using compute warehouse or some other warehouse, or any warehouse, all the results will be stored in uh, cloud services layer. Okay, the query results of one user can be reused by another user. How because when we are running a query, it is going and fetching the data from storage layer or virtual warehouses cache, and it is storing in result cache, which is available in cloud services layer. Okay, so any user with have the same role can be able to access this result cache data. There is no restriction to the users, but only the restriction is all the users who are trying to trying to reuse the result cache should have the same role. Okay, see, user can be different, but role must be same to take benefit of result cache. For suppose if we have a role of account admin or a sysadmin, a developer role. Okay, we have developer role. This role is assigned to I think this we have already seen when we are checking with role based access controls. The roles will be created that would be assigned to users. One user is there with Naveen, and some other user is there with name Sudhir, and third user Manikanta, then Sridhar. Okay, to all the four users, and the same role is assigned to uh, Varun. So Naveen is trying to access some data. So he executed a query. The results will be stored in result cache in cloud services layer. For suppose Varun is trying to access the same, if Varun is executing the same query, then it won't go and get data from storage layer. As Naveen already executed the same query and the results are available in result cache, Varun, if Varun execute the same query, the results will be getting from result cache only. Or if any other user is trying to use executing the same query, they also will get results from result cache, which is nothing but result cache reuse. Is it clear now? Okay, so user might be different but role must be same. The multiple users who are trying to who are trying to execute the same query, if the role is same, then they will use the result catch. No need to go to the storage and no need to use the compute resources. So this way, as I said, for us, compute cost and storage cost will be independent. For suppose if you are using a virtual warehouse for 5 minutes, it will cost for only 5 minutes. And if you are, the compute cost, Snowflake will charge based on seconds. But the default for the first time, if you are using the warehouse, for the first 1 minute it will charge default, and then after 1 minute, if you use 5 seconds, then it will charge only for 5 seconds. That minimal. Okay, and for storage, it will charge on terabyte basis. For 1 terabyte storage, if you use, it will cost around $23, like that. Okay, so in this way, if you are using the cache memory, you'll be saving compute cost and the performance also. You are achieving performance also, right? This is about the caches, metadata cache and results cache. Then we have one more. See, result cache expires after 24 hours of non-use. If you are not using the same query within 24 hours, the result cache will be expired, deleted. Okay, and we have one more scenario. See, for suppose if you are trying to execute the same query, 1 second, let me show you. This we have already executed, right? See, here you are able to see the column names which you have in your table. Okay, if you are trying to give, if you are trying to see this one I have executed already. I am trying to execute once again this query. So we have received the data. We have received the data. Where the column name is inventory underscore item dot underscore sk. If I want to change this column name, if I want to see the column name differently, if which is nothing but if you give the alias name. See here, you are trying to fetch data only for this column, but you want to see sk in this place, column place, and if you give the alias name, the query is same, but the display, it won't go and change any column name in your table. Okay, see, no, which is logically both the queries are same, but here you are giving alias name for this column, for this particular column you are giving sk. If you give the alias name, then it won't fetch the records from result cache. Why? Snowflake will see here. See what is the difference here. You are able to see sk, right? The column name sk, but it won't change any structure, table structure behind. Okay. So here it will go and fetch records from remote disk, which is storage layer. Why? Because as both the queries are same, why it should go and fetch the records from a storage layer? Why don't it fetch the records from result cache? Because it will check only the structure of the query. It won't check the query logically whether it is same or not. It will check the query, the structure of the query, whether it is exactly same as we executed earlier or not. If it is different, see here, it is a bit different, right? See here, select star from this table. Just we have given select this column. This is the column name from this table. But here select this column as SK. I'm trying to see this column data under this. I want to change this column name as SK. Here I have given alias name. So here it is going and fetching the records from table. It will check only the structure. Here there is bit change this keyword as SK. So that is the reason it has not used the result cache. See here, alias as we have given first time, right? If you run the same query again, same query, exact query, see the same query. I have not changed any query. You can see. If I run the same query again, 1 second. Here for the first time it took 27 seconds, right? I'm trying to run the same query again. See how much time it took? 76 milliseconds, less than a second. So this way, what you can understand, if you are running a query with alias name also, if you are running the same query, the second time or a third time, it will get the results from result cache. Okay, is it clear now? And if you give some other alias name again, it will again go and fetch records from remote disk, which is storage layer. See here. Here I have given alias name SK, but here I have given alias name this one, elementary underscore SK2. See here, it is taking more time, right? So here it is going and fetching the records from storage layer. Okay, if you rerun the same query again, then it will give the results from result cache. Clear? Is it clear now about the result cache? Okay, and one more scenario. So I'm saying the result cache will be stored for next 24 hours. But suppose if your table have 1,000 records, and if you change few records, if you delete some few records, or if you are inserting few more records, or if you are updating few records which are already exist, then how the result cache will behave? For suppose if the result in the result cache, all the already existing results will be stored, right? Already existing results set will be stored in result cache. If you are updating, and if you are, see, if you have 1,000 records, and you have used select statement on this, so you have retrieved select star, so command you have used, so you will retrieve all the 1,000 records. After that you have insert 100 more records, 100 records inserted. And now if you give select star, so now it should give you records of 10,000 plus 100, so total it should give 1100 records. It will show 1100 records. Okay, if it use the result cache, then in result cache, as you have you have used this command, only 1,000 records will be stored in result cache. 1,000 records, because at the time you are executing this query, only 1,000 records are available in this table. Okay, but after that you have inserted this time, as soon as you made any DML operations, any modifications to the underlying data which is stored in tables, that time it will the result cache will be hmm, see here, result cache expires after 24 hours of non-use. If you are not using the same query, then you won't use the result cache. So if you don't use result cache for 24 hours, then it will expire. And one more thing is underlying data changes. Underlying data changes. If there are any changes happen to that is already exist in table, then that time also the result cache will expire. Okay, so after you made some changes on the data and you are trying to get the data, then it will go and fetch from table only. Clear? Okay, this is how the result cache and metadata cache works. Okay, then what is meant by virtual warehouse cache? Virtual warehouse cache is nothing but, see, in our Snowflake architecture, in compute layer, we'll have the compute resources called virtual warehouses. What is meant by compute resource? Compute resource is nothing but compute nodes. The virtual warehouse is a group of compute nodes, I've said, right? So each compute node will have some specific cache based on the size of the virtual warehouse. Cache, memory, okay, CPU. It will have. So every warehouse has attached SSD storage. SSD storage is nothing but local disk cache only. Local disk is, see, we can call the virtual warehouse cache as SSD cache or local disk cache. These all are same. These are the names. We can call virtual warehouse cache as SSD cache or local disk cache. Okay, every warehouse has attached SSD storage. Every warehouse will have compute resources, right? Every compute resource will have the memory, which is nothing but SSD storage, or virtual warehouse cache, which is cache, and uh, compute resources also, like computing is nothing but CPU, memory is this one, like that. Okay. This has been used to store data from micro partitions that are pulled from storage layer. For suppose if you are executing a query, okay, if you are executing a query and you are getting the results, if you are trying to get the results from storage layer, if you are executing a query and getting the results from storage layer, then those results will be stored in uh, this warehouse cache also. Warehouse cache as well as result cache, both. Okay. So in results cache, we have mentioned the results will be maintained till next 24 hours. But in warehouse cache, how much time it will be stored? Until your warehouse is suspended. Until, for suppose if your warehouse auto suspend, I think we have discussed that also, right? What is auto suspend? What is auto resume, right? So if so, how much time the data will be available in uh, virtual warehouse caches until the warehouse is suspended. Okay, whenever we query in Snowflake, data get retrieved from remote disk storage. I've said remote disk is nothing but uh, storage layer, getting data from storage layer, and it will be cached in this warehouse memory, virtual warehouse memory. Will get results from storage layer, and that would be cached, that would be stored in this memory, warehouse memory, or SSD memory, or local disk memory. Based on your convenient, you can call anything. Okay. So data is in raw form, raw data. Will in storage layer, all the data will be stored in raw format, right? Micro partitions, compressed, right? So the same exact data which you get data from storage layer will be stored as it is in only the result memory. It will be stored in this cache. Okay. So as soon as your warehouse is suspended, Okay, when your warehouse is suspended, automatically the cache will be cleared or dropped or deleted. Okay, see, data in this particular cache, in this layer, in warehouse layer or compute layer, only the warehouses will be available, right? So the data which is available in this layer on any virtual warehouse will be available, will be active until the warehouse is active. If the warehouse is active, the cache memory also will be active. If the warehouse is shut down or suspended, then automatically the warehouse cache will be cleared. Okay, is it clear? Then why do we need? Then you can say in real time. See, for suppose, uh, if this guys reporting team is trying to build some reports, then this may helps. As I said, no, different teams may have different virtual warehouses, right? So if you are trying to retrieve more data frequently, then you can use this. Otherwise, if you are not, no, if mm, your organization is using only mostly on storage, and you rarely use the computations, then you can decrease the suspend time. Okay, like that it will work. Okay, so see here. So here, Snowflake optimizer can use partial data from warehouse cache and go deeper for remaining data that got updated. But suppose I've said, right, in result cache, if I've said, right, in result cache, if you're trying to retrieve data initially and after that the data is changed, then result cache will not work. Then the data, for suppose, let me show you. Let me give you an example. See, here you have 1,000 records, and you are getting records. These records from storage layer, storage, okay, or remote disk, from storage layer or remote disk. Same, remote disk and storage both are alias names. That's it. Okay, remote disk. Okay, so as soon as you are getting these results from storage layer or remote disk, those will be cached into virtual warehouse layer also, that we have discussed just before, just now. Okay, see, uh, see, data get retrieved from remote disk storage and cached in SSD. So here you are getting data from remote disk that will be cached in virtual warehouse cache, and then it will display in results, and the results will be stored in results cache. Okay, but suppose after that you have inserted 100 records, and then if you give the same command, it won't use result cache, right? Because after after you are using this data, the data is modified, so result cache will not work. So in that way, how virtual cache works is, if you are trying to get the data after inserting these 100 records, only the 1,000 records will be already cached in this cache, right, warehouse cache. So it will use 1,000 records from warehouse cache, and remaining 100 records it will scan from storage layer. Okay, see here, Snowflake optimizer can use partial data from warehouse cache. If any data is available which you are trying to retrieve in warehouse, it will utilize, and go deeper for remaining data. If some data is not there in virtual warehouse cache, then it will go to the table which is updated. If any data is updated, it will go and get from this data storage layer. Clear? Is it clear now? See here how the data will be retrieved from remote disk. See, you are giving this query, it will search in result and these both caches. If the data is not there, then it will go to the warehouse, and 50% of data is available here in virtual warehouse cache, and the remaining data should be coming from remote disk. Then only the 50% of data which it wants to get right, that will be scanned. Those micro partitions will be scanned instead of scanning all the micro partitions, and it will combine both the data which it got the results from a storage layer and virtual warehouse cache, and it will display. For the next time, it will be maintained in result cache. Okay, is it clear? See, in this way, you are giving a query. If for the first time, it will go and fetch the records, and the same data will be maintained, raw data information will be maintained in SSD cache, and the results, the same results will be maintained in results cache. Then it will be displayed. If you run the same query again, then it will. So in this way it is going right. First it will check here if it is available, why to go forward. Right away here it will come back and return the same results within less time, instead of going checking and uh, scanning all the micro partitions. Okay, clear now? Is it clear? See, this point we have already discussed. The time the result cache will be extended up to 30 days in some scenarios. Okay, this already we discussed. Okay, so I have mentioned everything. See, in this way the query execution will be happened. Query, let me zoom it if you are not able to see. Okay, as soon as you are trying to hit Snowflake with a query, then query will be received by Snowflake. You can the query not only with the help of worksheets. Okay, there are multiple ways. Even ETL team or a reporting team, they also might will connect your warehouse. Okay, see, for suppose if you know, not only Snowflake team will use Snowflake, right? You know, reporting team like Power BI, Tableau, they also will use the data which is stored in Snowflake. They might connect to Snowflake and give queries in different ways, JDBC, ODBC drivers, user interface, like that. Okay, then it will look in result cache whether this query is already used earlier. If it is used, then whether it is there in result cache. If it is used, definitely the result cache will be maintained, right? So then planner and optimization will happen. This is nothing but pruning. When we discuss with query optimization, we'll discuss how Snowflake will only go and search only the dedicated few micro partitions instead of searching all the micro throughout the storage. Okay, then it will virtual warehouse processing. See, I have said, right, we have just discussed, right? When you are giving a query, if the results are available, in virtual warehouse, it will process the remaining results. If there are any new few more results required, then it will go and scan the storage layer. Okay, then it will fetch, and these two results. For suppose 60% of the results are available in virtual warehouse cache, and the remaining 40 are scanned from no, the tables can will happen in storage, then those 60% and 40% will be combined, and those will be maintained in result cache. But the next time if you run the same query, then directly it will return the results from result cache. Clear? Is it clear now? Pruning technique. This I'll tell you when we discuss about query optimization. Okay, is it clear? Are any doubts? So how many types of caches we have? Three types of caches. Okay, metadata cache, results cache, and warehouse cache. Okay, and you have any questions? And if you are running a query with alias name, then from where it will get the results? As the query structure is changed, even it won't check the logically Snowflake. It will only check same as it is, all the keywords, all the as if the query is as it is, then only it will display the results from results cache. Otherwise, it will go and fetch the results from remote disk IO. Okay. So then you might have some doubt when you are trying to create a query, create a table. As I said, all the structures, those will be maintained in metadata cache, right? So you might have one doubt when you are trying to create a table. Okay, whether see here the compute warehouse is suspended. You go and create one table. See whether it is using compute resources or not. Whether it is used, it is not used, because this is not the here you are not working with data. They are not dealing with data manipulations. They are just trying to create a structure. This will be maintained in cloud layer, cloud services layer, not in storage layer. Okay, so to create this structure, you don't need any virtual warehouse, right? So, for suppose if you are trying to insert a data into this table, inserting the table is nothing but where the data will be stored. It will be stored in storage layer. Okay, in order to store the data, you need compute resources, right? See, as soon as you are trying to insert, it is using the compute resource or not. Okay, and for show tables, for show databases, for these also you don't need compute resource. Okay, for these also you don't need compute resource. See, I've selected the default warehouse. If I click on show databases, whether it is used compute resource? No, because all this data, the structures, details will be maintained in metadata cache, right? Okay, is it clear? Even if you want to describe the table, the structure of the table, it is not using any warehouse, so that you will minimize your compute cost. If you want to retrieve the data from the table, then it will use, because it has to communicate with storage layer. Here it is not used because it is already available in result cache, it seems. Okay, is it clear now? And still, if you have any doubts, we'll discuss. I think it's already 10:30. Okay, so for suppose one more scenario. For suppose if you want to check the query performance, then by executing the query multiple times, even it is possible to I mean, disable the cache also. It is possible to disable the cache also. How can you do that? See here, I've listed that command also here. See, alter session, set, use cache result. Use cache results. Results cache you can disable. If it is true, then it is enabled. If you give false, then the cache will be disabled. Let me try to disable and show you. See here, the cache, we have disabled the cache, and uh, I am trying to select. Okay, I'm trying to execute this query. See, okay, this already I think we have this data, right? Even if you okay, here I have disabled the cache, right? Okay, let me try to run any new query. One second, let me connect my charger. So if you disable the result cache, even earlier, if you rerun the same query, earlier we have seen, right? Even if you try to rerun the same query multiple times, it won't go and get the data from storage layer. It directly return the results from result cache. But if you disable the cache, if you disable the result cache, then always, even if you run the same query 100 times also, it will go and get the data from uh, remote disk. Okay, by default it will be enabled only. Mm, for your understanding, you know how to do that. I have shown this. Okay, is it clear now? I have listed all the commands here. Okay, so you just practice. Okay, I thought to at least start the cloning concept also today. But so here cloning. What do you mean by cloning? Cloning is nothing but, for suppose, if see here you have data in your storage layer, okay, and the micro partitions will be referenced in metadata. I have told, right, the metadata will be maintained in cloud services layer, metadata layer. It will have all the it will be organizing the data, cloud services layer, right? So if you are trying to uh, use the same table in some other uh, for suppose, if your table is, your data is in production environment, if some other reporting team or something, they want to uh, generate reports, instead of instead of directly go and um, co- go and build the reports and production data, if they want to copy the data into some other QA testing environment, if they do the changes in that environment, okay, they will copy the same data, but actual data will not be copied. Only the reference, the snapshot of the data will be copied. Okay, this way will for suppose your in your computer, if you have one file which have 1621 16 to 21 KB, if you copy the same file and if you store somewhere else, I mean some other folder, again that file also will occupy the same amount of storage, right? But in Snowflake, if you clone a table or a database or schema, it will not use it will not use again the storage. The storage will be remain same, but the micro partitions referencing the storage will be shared. Only the snapshot of the data will be shared. So once the data is the micro partitions data is shared, the metadata is shared, this table and this table both will act independently. You can make some changes on this source table and you also can change can perform actions on this clone table like that. Okay, we'll discuss this in detail with the scenarios also. Okay, uh, if you have any doubts, we'll take the doubts for next 5 minutes. We'll wind up. If you are interested, then I will continue this topic also. I'll try to finish this also. It may take 1 hour. Uh, if I continue, then it would be more no. It would be a kind of long session. If required, we'll take long session tomorrow. For now, I'll wind up this call. If you have any questions or doubts, we'll take and then we'll wind up for today. Tomorrow we will have class at 11 o'clock. I think somebody have some issues, right? So we'll have tomorrow Saturday, right? So Saturday also we'll have class at 11.